Hello everyone. Today in this session we are going to discuss about computer codes. Computer code help us to represent characters in a coded form in the memory of the computer. These codes represents specific formats which are used to record data. Some of the commonly used computer codes are BCD, BCD code, binary coded decimal, EBCDIC, extended binary coded decimal, interchange code, ASCII code, American Standard Code for Information Interchange, XS3 code, etc. First we'll see BCD code or weighted BCD code, or it is also called as 28421 code. BCD stands for binary coded decimal. It is one of the early computer codes. In this coding system, the bits are given from left to right. The weights 8421 respectively. The BCD equivalent of each decimal digit is shown in this table, that is the decimal digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and its BCD equivalent will be in the 4-bit form, that is 0000 for 0, 00001 is for 1, 0010 is for 2, 0011 for 3, 0100 for 4, 0101 for 5, 0110 for 6, 0111 for 7, 1000 for 8, 10001 for 9. This is the BCD equivalent of the decimal. Convert the decimal 537 into BCD. So how can we convert? Just we need to write the equivalent BCD form of the given decimal number. For example, 537. The equivalent BCD equivalent of 5 is 0101. The BCD equivalent of 3 is 0110. The BCD equivalent of 7 is 0111. Hence, the BCD form of the 537 is 0101, 0110, 01111. In the 4-bit BCD, only 2 to the power 4, 14 configurations are possible, which is insufficient to represent the various characteristics. Hence, 6-bit BCD code was developed by adding 2 zone positions with which it is possible to represent 2 to the power 6 64 characters. Next heading, XS3 BCD code or XS3 code. XS3 BCD code, it is a non-weighted code used to express decimal number. This code is used in some old computers. The following table gives the XS3 equivalent of the decimal from 0 to 9. So what we have to do, just we need to add 3 to the BCD number. For example, the BCD number is 0000. So what is the XS3 equivalent of that BCD number is 0011. Just we need to add 11 to the 11 means just we need to add 3 to the BCD number. The name XS3 code derived from the fact that each binary code is corresponding BCD code plus 0011, that is the decimal 3. The example, find the XS3 code representation of the decimal number 537. So XS3 code representation of the decimal digit is, first we need to convert that into BCD form. After that we should add 3 to that BCD form, then we will get the XS3 code. EBCDIC. It stands for Extended Binary Coded Decimal Interchange Code. This was developed by IBM and it uses an 8-bit code, hence possible to represent 256 different characters or bit combinations. EBCDIC is used on the most computers and computer equipment today. So it is a coding method generally used by larger computers like mainframes and the present latest. numbers and other symbols in the binary language the computer can understand. EBCDIC, it is an 8-bit code, therefore it is divided into two 4-bit groups where each 4-bit can be represented as one hexadecimal digit. Next heading, gray code. The reflected binary code or the gray code, it is an ordering of the binary numeral system such that two successive values differ in only one bit, that is binary digit. Gray codes are very useful in the normal sequence of binary numbers generated by the hardware that may cause an error or ambiguity during the transition from one number to a next number. So the gray code can eliminate this problem easily since only one bit changes its value during any transition between two numbers. Gray code is not weighted, that means it does not depend upon the position value of a system. This cyclic variable code, that means every transition from one value to the next value involves only one bit change. Gray code, also known as reflected code, because the first n by 2 values compare with those of the last n by 2 values, but in reverse order. The construction of n-bit gray code. N-bit gray code can be generated recursively by using reflect and prefix method, which is explained as: first you need to generate the code for n is equals to 1, 0 and 1 code. Take the previous code in the sequence 0 and 1. Add the reversed code in the following list: 0, 1, 1, 1 and 1 and 0. Now add the prefix 0 for the original previous code and prefix 1 for the newly generated code 0, 0, 0, 1, 1, 1, 1, 0. Therefore, gray code 0 and 1 are for binary numbers 0 and 1 respectively. Gray codes 0, 0, 0, 1, 1, 1 and 1, 0 are the binary numbers for binary numbers 0, 0, 0, 1, 1, 0, 1, 1 respectively. Similarly, you can construct the gray code for 3-bit binary numbers also. So this is the gray code conversion for when n is equals to 1, n is equals to 2, n is equals to 3. The conversion of binary to gray code. The gray code are used in rotatory and optical encoders, Karnaugh maps and error detections. The Hamming distance of the two neighbors gray code is always 1, and also first gray code and last gray code also has Hamming distance is always 1. So it is also called cyclic codes. The convert gray code from binary number. These are following steps for n-bit binary numbers. The most significant bit MSB of the gray code is always equal to the MSB of the binary code. Other bits of the output gray code can be obtained by XORing binary code bit at the index and the previous index. For example, for 3-bit binary number, let binary digits are B2, B1, B0, where B2 is the most significant bit and B0 is the least significant bit of the binary. So the gray code of digits are G2, G1, G0, where G2 is the MSB and G0 is the LSB of the gray code. So the binary conversion from binary to gray code is, if the binary code is 000, gray code will be 000, 001, 001, 001, 010, 011, 0111, 010, like this. Conversion of gray to binary code, reverse process. The gray codes are used in the rotatory and optical encoders, Karnaugh maps and error detection. The Hamming distance of the two neighbors gray code is always 1, and also first gray code and the last gray code also has the Hamming distance always 1. So it is called as cyclic code. To convert binary number from gray code, so following steps also you should follow. That is, the MSB of the binary code is always equals to the MSB of the given binary number. And the other bits of the output binary code can be obtained by checking the gray code bit at that index. If the current gray code bit is 0, then copy previous binary code bit, else copy the invert of the previous binary code bit. For example, for 3-bit binary number, let binary digits B2, B1, B0, where B2 is the most significant bit, B0 is the LSB. For gray code G2, G1, G0, G2 is the MSB, G0 is the LSB of the gray code. So this is the gray code conversion, just a reverse of that. And next heading is ASCII code. It stands for American Standard Code for Information Interchange. It is a 7-bit code which is possible to represent 2 to the power 7, that means 128 characters. It is used in most microcomputers and mini computers and in also mainframes. The ASCII code, pronounced as ASCII, it is of two types, ASCII 7 and ASCII 8. ASCII 7 is 7-bit code for representing English characters, has the numbers with each letter assigned a number from 0 to 127. For example, the ASCII code of the uppercase M is 77. So you can see the ASCII code. This is the ASCII code table. You can see all the ASCII codes. Here you can see 77. You can see this is capital M. Like that, there will be a separate code for the each and every number, ASCII number. Unicode. Unicode is a universal character encoding standard. This standard includes roughly 1 lakh characters to represent characters of different language. While ASCII uses only 1 byte, the Unicode uses 4 bytes to represent characters. Hence, it provides a very wide variety of encoding. It has 3 types, namely UTF-8, UTF-16, UTF-32. Among them, UTF-8 is most used mostly. It is also the default encoding for many programming languages. Next heading is UCS. It is very common acronym in the Unicode system. It stands for Universal Character Set. Furthermore, it is encoding system for storing the Unicode text. UCS2, we have two types, UCS2, UCS4. UCS2 uses 2 bytes to store the character. UCS4, it uses the 4 bytes to store the character. Next heading is UTF. The UTF is the most important part of this encoding system. It stands for Unicode Transformation Format. Moreover, it defines how the code represents Unicode. It has 3 types as follows, that is UTF-7, UTF-8, UTF-16 and also 32 it is there. UTF-7, so this scheme is designed to represent ASCII standard. Since ASCII uses 7-bit encoding, it represents the ASCII character in email and messages which use this standard. UTF-8, it is most commonly used form of encoding. It has the capacity to use up to 4 bytes for representing the character. It uses 1 byte to represent English letters and symbols, 2 bytes to represent additional Latin and Middle Eastern letters and symbols, 3 bytes to represent Asian letters and symbols, and 4 bytes for the additional characters. Totally 4 bytes. UTF-16, it is the extension of the UCS2 encoding. Moreover, it uses to represent 65536 characters. Moreover, it supports 4 bytes for additional characters. So, it is used for internal processing like in Java, Microsoft Windows, etc. UTF-32, it is multi-byte encoding system. Besides, it uses 4 bytes to represent the characters. What is the importance of the Unicode? As it is an universal standard, therefore it allows writing a single application for the various platforms. This means that we can develop an applications once and run it on the various platform independent in different languages. Hence, we don't have to write the code for the same application again and again. Therefore, the development cost reduces. Moreover, data corruption is not possible in it. It is common encoding standard for many different languages and characters. We can use it to convert from one coding scheme to another. Since Unicode is the superset of all encoding schemes, hence we can convert a code into Unicode and then convert it into another coding standard. It is preferred by many coding languages. For example, XML, Extended Markup Language, tools and applications use this standard only. Next heading is Advantages of the Unicode. It is a global standard for encoding. It has support for mixed script computer environment. The encoding has space complexity and hence saves memory. A common scheme for web development. It increases the data interpolability of code on cross-platform. It saves the time and development cost of the application. Next heading is the difference between the Unicode and the ASCII. Unicode, it is a coding scheme. ASCII, so we'll see the difference between the Unicode and the ASCII coding scheme. In the Unicode, it uses the variable bit encoding according to requirement. For example, UTF-8, UTF-16, UTF-32. But here in the ASCII code, it uses 3-bit encoding. As of now, extended form uses 8-bit encoding. That's it. Unicode coding, it is a standard form. ASCII code is not a standard form all over the world. Unicode coding, people use this scheme all over the world. Whereas the ASCII code, it has only limited characters, hence it cannot be used all over the world. Unicode coding, the Unicode characters themselves involves all the characteristics of the ASCII encoding. Therefore, we can say that it is a superset for it. But whereas in the ASCII code, it has its equivalent coding characters in the Unicode. In the Unicode coding, it has more than 1,28,000 characters. But in the ASCII coding, in contrast, it has only 256 characters, only 7 byte. This is the difference in between the Unicode and the ASCII code. This is about this session. In this session, we discussed about what is a computer code, what is a BCD code, what is a XS3 code, what is a ABCDIC code, what is a gray code, how to construct a gray code, how to convert binary code to gray code, and how to convert gray code to binary code, what is an ASCII code, the ASCII code table, and what is an Unicode, what is UCS, what is UTF, and what are the importance of the Unicode, what are the advantages of the Unicode, what are the difference between the Unicode and the ASCII code. So these are all the topics that we have discussed in this session. Thank you.